In problem C, we've got the same kind of setup. We've got a non-right triangle that we can start by drawing. So let's go ahead and do that, and we can fill in our angles and our sides that we have. So we have A, B, and C. We know that angle A here is 35 degrees. We know that its side A that is opposite it is 12. And we know that side B, which is opposite angle B, is also, it's 16. So remember, if we have an angle, which here is 35, and a side opposite it, and then either a side or an angle, then we can use law of sines to find the missing piece that matches up with either the side or the angle that we have, which means I can find the missing angle that matches up with side B, angle B. So we'll start off by using our law of sines, which would start off with sine of our angle we do have and matching it up with the side we do have, over what do we have? We have side B, and that has to match up with angle B, so it'll be sine of angle B. So let's see, filling in what we do know, we've got A, angle A, and side A. So we'll start off with sine of 35 degrees over side A, which is 12, equals sine of B, which we do not know. So we're switching to B. We do not know B, so I'm just going to leave that as a regular B that's unknown. However, side B we do know, so I can fill that in. It is 16. And now we can just find angle B using this law of sines by cross multiplying. By cross multiplying, we will multiply out the 12 times the sine B first. Technically, you can multiply the 16 times the sine of 35 first, but it doesn't really matter as long as you're cross multiplying. Equals, now on the other side, we can do our, 16 times our sine of 35, times our sine of 35 degrees. And last thing, so if we want to get the B by itself, we need to get the sine of B by itself. So we'll get rid of the 12 by dividing both sides by 12. And as a reminder, we'd like to hold off on rounding as long as we can. The more accurate our answer will be and are less likely that we will get a marked wrong on my math lab for rounding slightly off. So we'll leave this as sine of B equals, we've got 16 times sine of 35 degrees over 12. So our last thing that we need to do is get rid of the sine. How do you get rid of sine? You get rid of sine with inverse sine. So we'll do inverse sine to both sides. Again, don't forget your parentheses, inverse sine of this entire huge fraction. That will get rid of the sine and leave us with angle B now equals inverse sine of 16 times sine of 35 degrees all over 12. And as a reminder, you need to be in degree mode when we do this in your calculator. That also means that your answer will end up in degrees, which is fine because our other angle is in degrees. They're probably going to want degrees. So let's take a look. Now, using our calculator, what we end up with, again, be careful that we put parentheses around the entire numerator when we plug this into our calculator. So around the 16 times sine of 35, notice that we did do that here too when we used our calculator. And we get an angle, we will need to round this, of 49.9 degrees. Be careful. We talked about this a moment ago in the last problem, is that sine is positive in both the first quadrant and the second quadrant. So the angle we just found is in the first quadrant. It's 49.9 degrees. There's another angle, though, over here in the second quadrant that matches up with it, that will have the same value, that will have the same reference angle of 49.9 degrees. Its real angle, though, remember, starts at the x-axis and works its way around, which would be 180 minus the 49.9 degrees, which is 130.1 degrees. So the problem here is we now have two angles, which means we need to see if either one or both of them work, because we might have more than one triangle possible. So let's see what happens. So for angle B, what we've gotten are two possibilities. We got 49.9 degrees and 130.1 degrees. So let's fill these both in, just two separate triangles, and see what happens. So I've got a first triangle here on the left and a second triangle here on the right that are so far what we have for possibilities. Now notice if I fill in, let's see, the first one on the first triangle, the 49.9. Let's see.